Suppose the average caloric intake for women is 2,050 calories per day with a standard deviation of 175 calories. If we assume that caloric intake follows a normal distribution, that means it's going to have this mound shape, the total area is 1, the mean and the standard deviation, definitely that's all you need to draw it and use it. If it has that kind of a distribution, find the percentage of females in your class that consume more than 2,000 calories per day. So we can do this with our z-scores, and if we draw in our distribution, see if you can do that. All right, I've written in my x values and I wrote them sideways and I hope you can read them, but those are giving us the number of calories for each of our regular markers, the whole number of standard deviations away from the mean. And then down here I have the z-scores, which tell you how many standard deviations away from the mean each of those markers is. Now we're looking for the ones that consume more than 2,000. And I see 2050 and 1875, so 2,000 is somewhere in between here, and then we want to the right, we want more than. First I want to find a z-score. So my z-score is going to be x minus the mean over the standard deviation, 2,000 minus the 2050 over the standard deviation of 175. So 2,000 minus 2050, and we should get a negative number, negative 50 divided by 175, because we knew we were to the left of the mean, so this should not surprise us. And the z equals, so that is negative 0.29, and I went ahead and drew it on my z-score, or on my distribution, and we were talking about more than this number of calories per day. So we have a little chunk here, and then we have, change my color, we have a pretty big chunk to the right, and it's to the right of the mean, so I know that area is 0.5, and so I'm going to put an arrow for that area is 0.5, but I need to find what this area is. And that one, I have to think about the symmetry, that if I have a distribution, so remember the symmetry of the distribution tells us that from 0 to 0.29 on the right hand side, where I have a positive 0.29, that area there is going to be the same as this area that I'm looking for, which is to the left 0.29 from the mean. So I look this one up using the 0.29, and it's 0.2, so I'm looking here, and then 0.9, so I'm looking 0.09 right here, and where those two intersect is 0.1141, and that means this area is 0.1141, which also means the area to the left has the same size, 1141. And so this little sliver to the left has that 0.1141, and then the big chunk to the right is half of my distribution. So I'll add those two together, 1141, 0.5, and I get 0.6141. 0.6141 is the probability or the decimal value of the females in the class that consume more than 2,000 calories. So if I need a percent, which they're asking for, I just convert it to a percent. So 61.41% of females consume more than 2,000 calories per day. So using the symmetry of our mound-shaped distribution and thinking about from 0 to that same z-score but on the right, we could find the area, and then we can make the conclusion that this sliver here will have that same area even though it's to the left of the mean, and then we want this area plus this whole right hand side, so we add those two together to get 61.41%.